Okay, let me check something real quick. Yep, my mic's working. Okay. All right. So, greetings, YouTube. So we have a beautiful mind here. We have like a series of like 9 questions from calculus. So what I did, I just made individual videos for each one. Long story short, it's a struggle to kind of load them. So it seems like the easier for me to just live stream them. So what you're about to experience is like a live stream of my responses for those 9 questions. Okay. All right, greetings, YouTube. Beautiful mind here. So we have this first question in a series of 9. This comes from section 3.7, question 16. This is calculus, early transcendentals. I think it's Stewart. And so the question goes: a stone is dropped into a lake, creating a circular ripple that travels outward at a speed of 40 centimeters per second. Find the rate in centimeters squared per second at which the area within the circle is increasing after each of the following. And then what can you conclude? Okay. So a few notes here. So it says that it creates a circular ripple traveling outward at a speed of 40 centimeters per second. Let's start with the area of a circle, right? So then area of a circle is what? Pi r squared. If it's traveling out at a speed of 40 centimeters per second, that means that what our the rate of change of our radius with respect to time that means our radius based on time is going to be 40 times t, right? For instance, after like a second, the radius should be 40 centimeters, right? After 2, right? So this is based on time, okay? So if that's our radius, then the area should be what? Pi r squared. So that's going to be pi times 40t squared. And then if we keep going, what is that? 1600 pi t squared. Okay. So then the area based on time is going to be the 1600 pi t squared. If we want the rate of change of the area of the circle, so we want dA by dt. So if we take the derivative, the 2 comes down, that's a 3200 pi t centimeter, and the units here are centimeters squared per second. Okay. Okay, so now we have our A prime in terms of t. So now that we have our formula, and I'm going to rewrite this instead of dA by dt, I'm going to write it as A prime of t. And this guy here, I'm going to write it as A of t. Oops, let me undo. This is going to be A of t. It's the same thing, just different labels. Okay, so then with that, for part A, let me see, find the rate in centimeters squared per second at which the area of the circle is increasing after each of the following. So then for part A prime of 1 second. So if we plug in a 1, we're going to get 3200 pi. So that's the result for part A. At least it should be, provided I'm not making mistakes. B, so then A prime of after 4 seconds. So if we plug in a 4, 0, 0, 8, 12. Pi. Again, the units here are centimeters squared per second, centimeters squared per second. Okay. And then after 6 seconds, so we want A prime was 6. Well, let's see, 0, 0, 2, 19 centimeters squared per second. Okay. All right, and with that, we're going to end the session here. And from one beautiful mind to another, have a wonderful day. Take care. Peace. All right, greetings, YouTube. Beautiful mind here. We have this question that comes from calculus. We're asked to find the derivative of the function. We have this y equals the square root of x over x plus 5. So first, I'm going to rewrite this guy as as a rational power, right? So to the power of a half. So we got this x plus 5 under x. And instead of saying square root, I'm going to rewrite it as to the power of 1/2. Okay. So then when I go to take my derivative to find my dy by dx, I'm going to use the chain rule. So the chain rule, the derivative of the outside function times the derivative of the inside function. So the outside function, that means that power comes down. Right? So the 1/2 comes down. Inside stays the same. And then now we subtract 1 from that power. Now it's to the power of a negative 1/2. Then we need to say times the derivative of the inside function. So when we take the derivative of the inside function here, we have to apply the quotient rule, right? The way I remember quotient rule is low d high minus high d low, all over low low, right? I know it sounds funny, but that's how I remember it, right? So low d high minus high d low over low low. So low, which is the bottom, so the bottom times the derivative of the top, the derivative of x is just 1. So that's low d high minus high, which is this guy, d low. The derivative of the bottom of the denominator here is also going to be 1. And then all over low low, so the bottom squared. So whenever I'm taking the derivative of a fraction or a quotient, low d high minus high d low over low low. Okay. So then at this point, it's just a matter of simplifying this guy, expanding things out, combining like terms. Like for instance, this x is going to be canceled by that one. Okay. So we have this rational expression to a negative power. So that's really 1 over the square root. And so I'm going to rewrite that first factor and another. So the half just comes down. So you could almost look at it like x to the power of a negative 1/2 divided by x plus 5 to the power of negative 1/2. So then because of the negative exponent, we can essentially flip it. And so I'm going to rewrite it as x plus 5 to the power of a half over x to the power of a half. Okay. And I'm going to say times, over here we have this x plus 5 squared under 5. Okay. And then we typically don't like to leave radicals in the denominator, so we're going to rationalize by, in this case, we're going to multiply by 1 in the following form. I'm going to generate a little bit of space here. So I'm going to multiply by 1, because remember that denominator is really the square root of x. Yeah, let me just rewrite it. I think that'll be a little bit better here. So we got the 1/2. So the x plus 5, let me see, x plus 5 square root and the square root of x. And then this guy I'm just going to leave it, x plus 5 squared. Okay. Didn't leave myself any space. So now to rationalize, I'm going to multiply by 1 in the form of square root of x over square root of x. All right, so it's not going to change the answer, it's just going to manipulate the form. Let's see. So let's do the bottom. I guess we can just leave it as 2x times x plus 5 squared under, on top, looks like we're going to have 5 times the square root of x times x plus 5. Okay, let's see if we can, oh. Negative, okay. Okay. And then the second part of this question, we're asked to find the derivative of this guy. Okay. So here it's like taking the derivative of exponentials, right? So it's similar to like when we take the derivative of e dx, but there's a caveat because the base of the exponent is not e. The base here is 6. So when we go to find r prime of t, or the derivative, just like e, it's going to be its own derivative. So we're going to have 6 to the power of 2 square root of t. But then we need to say times the derivative of the power. So we got to do chain rule again. The 1/2 comes down. So it's going to be t to the power of a negative 1/2, right? Because that's t to the 1/2. The 1/2 comes down and cancels out the 2. Then you got to say a half minus 1 gives us the negative 1/2. But then the caveat here, we also need to say times the natural log of the base. So that's going to be natural log of 6. Okay. So then ultimately it looks like we're getting that r prime of t square root of t. So I'm going to write it as, let me see, 6 to the power of 2 times the square root of t times the natural log of 6 all over square root of t. Okay. Again, sometimes they don't want you to, they might want us to rationalize here, so you would, you can multiply by 1 in the form of square root of t over the square root of t. On bottom, we're going to be left with t. On top, we're going to have the square root of t times the stuff that you see on top already. Okay. Okay, I'm going to go with this. I'll go ahead and write the alternate that it might be looking for. I'll say or. So if we rationalize, I'm going to say times here. So I'm going to write it like this. Natural log of 6 times this 6 to the power of 2 times the square root of t times the square root of t all over t. So it might look for this. It might accept this one. If it doesn't accept the above one, it might accept this. These are the same way of. It's the same answer written two different ways. Okay, and with that, we're going to end the session here. And from one beautiful mind to another, have a wonderful day. Take care. Peace. All right, greetings, YouTube. Beautiful mind here. We have question 3 in a series of 9. It comes from calculus. It says that if f and g are the functions whose graphs are shown, let u of x equal f of g of x, v of x equal g of f of x, and w of x equal g of x. Find each derivative if it exists. If it doesn't, explain why it doesn't exist. Okay. So we have, this is composition of functions, which means one function inside of another function. And when we go to take the derivative, we're going to be applying the chain rule. Each function's graph is shown. Also, a concept to keep in mind is that the derivative is the slope of a tangent line at a point. All right, that's essentially what we're going to be doing. Okay, so let's start with the first part. Let me see. So let's see, for instance, for part A, if our u of x equals f of g of x, then our u prime, so chain rule is the derivative of the outside function times the derivative of the inside function. So there should be f prime of g of x times g prime of x. Okay. Okay. Okay, and so for parts A, B, and C, they all want to be evaluated when x is 1. So in order to find u prime of 1, it should be f prime of g of 1 times g prime of 1. Okay. What is g of 1? So when x is 1, g in blue is 5. All right. So g of 1 is 5. Okay. So then when we go to find u prime of 1, that's really going to be f prime of 5 times g prime of 1. Okay. So when x is 5, our f, which is the red, so we want the slope of the tangent line when x is 5 on the red. I think that slope, let me see, from here to here, it's a negative 1 by 4. So f prime of 5 is a negative 1 by 4. G prime of 1, so when x is 1, what's the slope on g? I think that's a negative 1, so down 3 and right 3, so it's a negative 1. Okay, so then from here, I get that u prime of 1 is a positive 1 by 4. Okay, that's what I got there. Okay, so then next, so that was what, part A. So then part B, we're going to do v prime of 1. That's going to be g prime of f of 1 times f prime of 1. Okay. So then let's go ahead and find f of 1. So when x is 1, f is 2. So f of 1 equals 2. So then v prime of 1 is going to be g prime of 2 times f prime of 1. Okay, let's look at g prime of 2. So x is 2, g is our blue. So the slope of the blue when x is 2, let me make sure I'm doing that right. Okay, so the slope of g when x is 2, we go down 1, 2, 3. It looks like it's a negative 1. And then f prime, the slope when x is 1 on f. 1, 2, 3, 4. So the rise is 4 and the run is 2. So rise over run, 4 divided by 2 is 2. So it looks like f prime of 1 is what, 2. So then ultimately I'm getting that v prime of 1 equals negative 2. Okay. And then part C asks us to find w prime of 1. So that's going to be g prime of g of 1 times g prime of 1. Okay, let's first find what is g of 1. So when x is 1, g is 5. I think I'm out of space. So it looks like g of 1 is 5. So then w prime of 1 is going to be g prime of 5 times g prime of 1. So the slope when x is 5 on g, 5 and g, I was kind of hoping that one of these would have given me a 3, but, you know, or tried to get to one of these. We came close, but I don't think we did an f prime of 2 anyway. Kind of wanted one of them. Anyway, let me focus. So the slope when x is 5 and when x is 1. So when x is 5, let me see, rise over run, 1, 2, 3, 4. So positive 1, 4, and a negative 1. So I'm getting that w prime of 1 equals a negative 1 by 4. Let's move that there for the time being. Okay, I know it's a little bit small. Let's see. Just kind of, let me do a quick scan. So f of g of x, so this should be f prime of g of x times g prime. G of 1, when x is a 1, that's a 5. So then f prime of 5 times g prime of 1. Okay, I'm just going to go with these results. So then Yeah, just check it, and if you know if anything looks out of order, just let me know, and we'll go back and fix it. And so with that, we'll end the session here. And from one beautiful mind to another, take care. Peace. All right, greetings YouTube, beautiful mind here. We have this question from calculus where we are asked to differentiate. So here we're going to be applying the product rule for differentiation, which is the first times the derivative of the second plus the second times the derivative of the first. Right? Okay, so that's what we're going to apply. So we have this f prime of z. The first is this guy times the derivative of the second. Okay, so that's going to be what, 9. The derivative of e is itself times the derivative of the power. The derivative of z is 1. So that's the first times the derivative of the second plus, I'm going to drop down a line, the second times the derivative of the first. Our derivative of 9 is 0. The derivative of negative e to the z is itself negative e to the z. Okay, I'm going to get this on one line. Stop. Okay, so we said the first times the derivative of the second plus the second times the derivative of the first. Do we have anything we can factor out? Combine like terms. We could FOIL, expand. I think what I'm going to do is just expand it all the way out and just try to combine like terms. Let me see, because I don't see anything that's factoring. Oh, wait, is that yeah, let me expand it out, because it looks like it's going to simplify some. So if we FOIL the first, we're going to get, let me see, 81. So first times first, outer times outer is plus 9e to the z. Inner times inner is minus 9e to the z. And last times last, minus e to the power of 2z. Right? Because we say, when we multiply fractions of the same base, we add the power. So z plus z is 2z. And over here on the right, we need to distribute this guy. Let me see. So minus 9z e to the z. That's a lot going on. And then minus e to the 2z. Okay, I think we got some cancellations going on here. So it looks like this cancels this. Oh, that didn't cancel. I was kind of hoping it would. Okay. So then ultimately it looks like we're getting, I'll try to put it in some sort of descending power order. Now we might be able to factor this, because, so e to the 2z, here, let's do this. So we got this negative 2 e to the 2z, all right? So this has been accounted for, that's been accounted for. Then we have what? Minus 9z e to the z. This has been accounted for. And then plus 81. Okay, I was kind of hoping that we could do a factoring, but it looks like the numbers aren't panning out properly. If we, let me see, let me just, give me a moment. Let me see. 8 times 2 is 16, so 162. Two numbers that multiply to give us, let me just check real quick. So if I look at the factors, I got this negative 162, right? I said the 2 times the 81. 81 is what, 9 times 9? Okay. Can we find two factors that add up to -9? Let's just go through the list. Because if so, then we can factor this guy. So -1 and 162, but those don't. We're looking for two numbers that add up to -9. Let me think. Yeah, I don't really think it's gonna work. I just want to check. I think it'll go quickly. -2. Let me see. And 81. All right, but these don't work. We can do 3. If we've used a 3, 9 times 6 is 54. There's no 4, there's no 5, there is a 6. So the 6 comes here. If we've used this 6 already, 27 is left over. Those add up to 21, so these aren't the two numbers. There's no 7, there's no 7, there's no 8, there is a 9. All right, we can do a 9 from there. So if we've used this 9, 18 is left over. Uh-oh. Those two numbers. So these two numbers add up to +9. We want a -9. So then what we're going to do, we're going to do 9 and -18. So what this means is that the above can be factored. Okay. Okay. So what I'm going to do, I guess we could use the box method for factoring. All right. So it kind of goes something like this. And okay. So in the upper left-hand corner goes a leading term. That e to the 2z, I'm going to rewrite it as e to the z squared, all right? So it's going to look like this. -2 e to the z squared, okay? And the bottom right goes the constant, which is 81. And then that -9z, see, something is missing. This is z missing somewhere. Or either I have an extra z. Let me go back and check. It can almost be factored, but it's a little off. That extra z is throwing things off. So I think I'm going to just leave it in the above line. Because otherwise it would have been the 9 and the 18. It's just the extra z is throwing it off. And I think it's supposed to be there. Okay. So with that, I'm going to stop here with the green box. I was going to try to factor it, but again, there's an extra term in there that's not panning out. And so I'm just going to stop here. Okay. And again, what you have to do is just check it. If it doesn't work or if anything looks off, we'll just have to come back and try to correct it. Okay. Let me check one more time. All right, I'm just going to go with it for now. Okay, so that was that one, and then this other one is here. So given this f, we're asked to find f prime and f double prime. Okay. So f prime, we're going to take the derivative. We have to use the product rule. So that's the first. and that's a 7. First times the derivative of the second, so this is going to be e to the x, plus the second times the derivative of the first. Okay. So that's f prime. Okay. And then, so f double prime just means we're taking a derivative of the derivative. So for that first term, we need to use the product rule, which is going to be the first times the derivative of the second plus the second times the derivative of the first. First times the derivative of the second. Okay, that's the first term. And then the second one, we got to do the product rule again, which is the first times the derivative of the second plus the second derivative of the first, 3642. We have some like terms. Okay, I think this one is alone. X to the 7 e to the x. X to the 6 e to the x. X to the 6 e to the x gives us 14. X to the 6 e to the x. And then the last one, that 42 x to the 5 e to the x. First times the derivative of the second plus the second times the derivative of the first. So it's 42 x to the power of 5. Okay. Okay. And so with that, we're going to end the session here. And from one beautiful mind to another, take care. Peace. All right. Greetings, YouTube. Beautiful mind here. This question comes from calculus. This is question 5 of a series of 9. First, we're asked to find the derivative of this function. Okay. So here, what I'd like to do first is, it's not officially distributing, but I'm going to rewrite this in the following way. So this numerator, we have this u cubed minus 2. I'm going to isolate that, say to the power of 9 over u cubed plus 2 to the power of 9. Okay. So first I'm going to apply the quotient rule, which is the bottom times the derivative of the top. The derivative of the top looks like it's a 9 you got this u cubed minus 2 times 3u squared. Okay, so that's the bottom times the derivative of the top minus, so this really all it needs to be on one line. Minus, let's see, bottom times the derivative of the top minus the top times the derivative of the bottom and then it will be all over the bottom squared. Let me get this on one line. So I think that's about the best I'm gonna be able to do. This one, you know what, I could, let's drop this down the line just to try to expand the font a bit. Try to give ourselves as much space as possible. Okay. Guess we don't need that one. Okay, do we have like factors or like terms that we can factor out? Okay, I see a u cubed minus 2, and I see a u cubed plus 2, and I see a 9 and a 3u. Okay. I'm going to try to color code this. So they both have a 9, right? So let's just factor out that 9. I see at least they both have a 3u squared. So I'm going to put that here. Okay. U cubed plus 2, u cubed plus 2. They both have at least 8 of those. U cubed minus 2, u cubed minus 2. They both have at least 8 of those. Now what's left over? Okay. Run out of space again. So we took out 8 from both. So in the first one, it looks like it's a u cubed plus 2 minus, in the second one, a u cubed minus 2. I'm going to go ahead and distribute the negative. U cubed, it becomes a u cubed plus 2 because of the negative. Everything else I was able to factor out. Okay, and this is going to be all over u cubed plus 2 to the power of 18. This is equal to g. Okay. So then, looks like this cancels this. That's what, a 4? So 4 times 3 is 12, times 9 is 90 plus 18, 108. So it looks like we have a 108 u squared now we could combine those. Okay. Six. So then u to the 6 minus 4 to the power of 8 all over. Now that is difference of squares. I mean, is anything gonna cancel? And something could cancel. So let me back up a step, because it looks like we have another cancellation that I neglected. Let's keep that 108 though. So the cancellation that I'm seeing right here, we got a u cubed plus 2, u cubed plus 2. We've used 8 of them. So 8 of these cancels 8 of those. It leaves 10 down here. Okay. So I think this is a u squared, because that was 4 times 3 is 12 times 9 was 108. U squared, the purple is gone. This burgundy is left over. All over okay. I think that's about the best we can do there. And this is G prime. Okay. Well, okay. Okay. And then the second part of this question, or another portion of this question, so here we're asked to find the derivative. Okay, so this is like a chain rule combined with exponentials, right? So the derivative of an exponential is itself, let me see, but there's a few caveats. I'll just call it dy by dx. So 1 is its own derivative, 6 to the power of 7 to the power of 8 to the power of x times the derivative of that power, 7 to the power of 8 to the power of x. But then we need to say what? Times the derivative of that power, 8 to the power of x. Okay. But then every time we took those powers, we also needed to say times the natural log of the base. So natural log of 6, natural log of 7, natural log of 8. And that's about the best we can do there. Let's try that again. Yeah. Yeah. Okay. And so with that, we're going to end the session here. And from one beautiful mind to another, take care. Peace. Greetings, YouTube. Beautiful Mind here. We have this is question 6 of a series of 9 from calculus. We're asked to find the derivative of the function. We have g of x equals e to the power of x to the power of 4 minus 3x. So again, with e is its own, the way we find the derivative of e is its own derivative, then we say times the derivative of the power, all right? So then g prime, e, just rewriting at first, times the derivative of the power, and I think that's it. And so with that, oh wait, is there another one? Okay, I think that was it for that one. And so with that, we're going to end the session here. And from one beautiful mind to another, take care. Greetings, YouTube. Beautiful mind here. We have this question 7 of a series of 9 from calculus. We're asked to consider this function. We're asked to simplify by rewriting f of t using a negative exponent and no fractions, and then find the derivative of the simplified function. Okay, so we have this 1 over 7t plus 1. So we can rewrite that as 7t plus 1 quantity to the power of negative 1. Okay, so then this f of t, the first part, let me see, we have this 7t plus 1 to the power of negative 1 and then to the power of 5, right? So when we say a power to another power, we multiply. So then ultimately that's going to be 7t plus 1 to the power of negative 5. Okay, so that should be the result for the first part. Well, here, so then let's find the derivative or take the derivative. So again, we have this f of t, 7t plus 1 to the power of negative 5. So then when we go to take the derivative, the negative 5 comes down. So we're applying the chain rule here. That's going to become a negative 6. And then we got to say times the derivative of the inside function. So this is going to be what, 7? So then ultimately, we're getting that f prime of t, negative 35, 7t plus 1 to the power of negative 6. Okay. And so with that, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care. Peace. All right, greetings, YouTube. A beautiful mind here. I'm sorry, I can get rid of that. That's okay, me. I don't see. Let me see if I go like this. Yeah, and I don't think there's an option to learn it. There it is. Okay, that's fine. Cool. Okay. All right, sorry about that. So, beautiful mind here. We have this. This is question 8 of a series of 9 from calculus. We're asked to find dy by dx by implicit differentiation. Okay. So implicit differentiation, like so far we've been doing the derivative with respect to y. We're still going to do that, but this is like, notice that I think in most of our examples, we had like y in terms of x. We had one function in terms of another. Now here, so it was explicitly y in terms of x. Now we have to differentiate implicitly. Notice that we have x and y on both sides of the equation, right? So let me see. The way I usually go about this, whenever I take the derivative of a variable, I'm going to put d that variable, right? So if I take the derivative of x, I'm going to put dx. If I take the derivative of y, I'm going to put dy. And then at the end, I'm going to use algebra to come back and isolate my dy by dx. And most of the time, that usually works for me, right? Okay. So the derivative of e is itself. Now, let me think about that. Okay. So again, the derivative of e is itself times the derivative of the power, right? So we have to use the quotient rule, the bottom, the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Okay, so that looks like the derivative of the left. The derivative of the right, so 9x, that's just going to be a 9 dx. I took the derivative of dx, so I put dx. The derivative of negative y is negative 1, but because I took the derivative of y, I put dy. Okay, so now I'm going to expand this all the way out, and then what I'm going to do is any term that has a dy, I'm going to move it to the left. Any term that has a dx, I'm going to move it to the right. So first I'm going to get rid of the fraction by multiplying both sides by y squared. All right, to get rid of the fractions. So I'm going to say this times y squared and this whole side times y squared. So then we have to distribute here. And these guys are going to cancel. Okay. Also, I am going to distribute this function e. Okay. So then it looks like on the left we have y e to the power of x over y dx. Okay. Then we have a negative x e to the power of x over y dy. Okay. Then over here, it looks like we have a 9y squared dx minus y squared dy. Okay. Again, any term that has dy, I'm going to move it to the left through algebra. Any term that has a dx, I'm moving it to the right. So I'm going to add this y squared dy to both sides. Okay. So on the right, they'll cancel. I'll finish with my dy's on the left. Let me see, dx. Let me move that guy. So then I'm going to subtract this dx. So it's just minus y e to the x over y dx. I'm going to subtract that from both sides. Okay. So on the left, these guys are going to cancel. So let's account for these augmentations. So on the left, I'm going to have this y squared dy minus x e to the x over y dy. And then on the right, it looks like we have this 9y squared dx minus y e to the x over y dx. Okay. Notice we have our dx's on the right, our dy's on the left. In both cases, we're going to factor out that differential. So we're factoring. Factoring. Okay. Probably should have drew those arrows the other direction. I mean, it's still the same thing. Okay. So if we factor out dy on the left, we're going to be left with what? Y squared minus x e to the power of x over y dy. On the right, 9y squared minus y e to the x over y dx. So now we use algebra, right? We're going to just divide so that we finish with dy by dx. So then ultimately our dy by dx, on top we're going to have this 9y squared minus y e to the x over y. On bottom, y squared minus x e to the x over y. Let's see. Okay. And so with that, we're going to end the session here. And from one beautiful mind to another, have a wonderful day. Take care. Peace. Greetings, YouTube. Beautiful mind here. And we have question 9 of a series of 9 from calculus. We're asked to consider the following. For part A, we're asked to find y prime by implicit differentiation. B, solve the equation explicitly for y and then differentiate to get y prime in terms of x. And then C, check that your solutions to part A and B are consistent by substituting the expression for y in your solution for part A. Okay. So let's start off with the implicit differentiation. Again, I'm just going to take the derivative like normal. Whenever I take the derivative, I'm going to put d, that variable, right? So when I take the derivative of x, I'm going to put dx. When I take the derivative of y, I'm going to put dy. Then I'm going to use algebra to isolate dy by dx. That's typically how I do my implicit differentiation, okay? So then for part A, we have the square root of x plus the square root of y equals 9. So remember, the square root of x is the same as x to the power of a half. So I'm going to bring the power down. So then we'll have 1/2 x to the power of a negative 1/2 dx plus 1/2 y to the power of a negative 1/2 dy equals, the derivative of a constant is 0. Okay. Okay, if we use algebra, subtract that first term from both sides, we'll get 1/2 y to the negative 1/2 dy equals a negative 1/2 x to the negative 1/2. Wait a minute. That's supposed to be a dx up there. Right? Because we took the derivative with respect to x. So over here, this is going to be a dx. Okay. Before I isolate my dy by dx, I'm going to rewrite these as fractions. So on the left, on bottom, I'm going to have 2 times the square root of y under dy. All right, because that negative exponent means it's in the denominator. And then I just put it back into radical form. And then on the right, on bottom, I'm going to have 2 times the square root of x under a negative dx. Now I'm going to use algebra. You can like cross multiply because I want to isolate my dy by dx. On the right, it looks like we have a negative 2 times the square root of y over 2 times the square root of x. Okay. guess you can leave it as, let me see, y over x square root, like that. That's fine. Okay, so this is the result I got for that first part. Let's try that again. And then part B, solve the equation explicitly for y and then differentiate. Okay, so for part B, I knew it was about to happen. So for part B, again, we started with what? Square root of y plus the square root of x equals 9. So we're asked to solve explicitly for y. Okay. So then we're going to have the square root of y equals 9 minus the square root of x. Let me just check one thing real quick. That's fine. What we have is fine. This doesn't really make a difference, but I'm just going to do this anyway just to be consistent. We still get the same thing here. Subtract the root x. And then square both sides. So we get y equals I'm gonna leave it like this. So when I isolate y, I get this. So then let's take the derivative. The 2 comes down. And the derivative of the inside function. Okay, we need to simplify. So it looks like this half is canceled by this 2. Let's see. So it looks like we have a negative 9 over the square root of x. Minus 1. Nope. Double negative is a positive, so plus 1. Okay. So then we're going to add 1 in the form of square root of x over square root of x. Let's see, do we need that? I mean, yeah, let's just go on. Let's see, so we got this negative 9 plus the square root of x over the square root of x. Okay, so when I did the second one, I got something like this. So then what we want to do, I think part C, it said to take that y that we found when we isolated y and plug it into our answer for part A to show that these are the same. Okay. So let's do this. When we isolated y, we got it right there. So we'll take a copy of this guy. Yeah, this one here. Paste. And then let's also take a copy of our solution from part A and combine those two pieces. Okay. So we're going to take this y and plug it into the solution for part A. So then we should get dy by dx equals our y 9 minus the square root of x quantity squared over x square root. Okay. So then our dy by dx, those cancel. Negative 9 plus the square root of x over the square root of x. Is that what we got from above? Negative 9? Yep, we got the same thing. Okay, so it does check out. A little bit of keeping track of it. It can get a little bit hectic, but you know, it works. You just gotta. It's an adventure, a true adventure. Let's see. I don't think I can get all of this to show. It's about 3 pages. I'll just do a slow scan to do a quick review. Maybe something like this. Maybe I'll show each part. So for part A, we got our dy by dx was that. For part B, we got our dy by. So part A still had a y there. Part B was dy by dx explicitly in terms of x. For part C, we took the y that we solved for with our solution for part A. We plugged in that y into our solution for part A, and we got the same result that we got in part B. Okay. And so with that, we're going to go ahead and end the session here. And now from one beautiful mind to another, have a wonderful day. Take care. Peace.
You not speaking to your own mom. For her to know what was going on all those years and not.
Not too bad. All right, and so with that, we're going to end the session here. And for one beautiful mind to another, take care. Peace.